Welcome back to episode 2 of Fiber in Practice. In this episode, we're focusing on cryptography and secure file transmission, two critical concepts used every day to protect sensitive information across networks and systems. I'll be demonstrating how data can be encrypted before transmission, remain protected while traveling across the network, and then be decrypted only by authorized users with correct credentials. Before we move into the hands-on demonstration, it's important to understand what cryptography actually is. Cryptography is the process of protecting information using encryption and secure mathematical processing. In simple terms, it takes readable information called plaintext and converts it into unreadable encrypted data known as ciphertext. Cryptography is commonly used to protect sensitive information during both storage and transmission. That includes things like passwords, financial data, emails, secure messaging, and encrypted web traffic. The goal is to prevent unauthorized access so that even if someone intercepts the data, they still cannot read or understand it without the correct decryption credentials. Now that we understand the purpose of cryptography, let's look at how encryption helps support confidentiality. One of the primary goals of cryptography is protecting confidentiality. Encryption works by converting readable plaintext into unreadable ciphertext using cryptographic algorithms and secure keys or passphrases. Once encrypted, the information becomes unreadable to unauthorized users. Only someone with the correct decryption credentials can restore the original data back to the readable form. This is extremely important in cybersecurity because encryption helps protect sensitive information, prevents unauthorized access, and secures data while it's being transmitted across networks. Even if encrypted data is intercepted during transmission, the context still remains protected unless the attacker has proper decryption credentials. Next, let's look at the specific types of encryption being used in this demonstration. For this demonstration, I'll be using symmetric encryption with GPG. Symmetric encryption uses a single shared passphrase for both encryption and decryption. That means the same passphrase used to encrypt a file is also required to decrypt the file and restore it to original data. This type of encryption is commonly used for file protection because it's fast, efficient, and relatively simple to implement securely. In this demonstration, GPG symmetric encryption will be used to protect sensitive information using a secure passphrase before the file is transmitted across the network. Now let's look at how encryption protects data while it's moving across the network. Another major advantage of encryption is secure transmission across the networks. When sensitive data is encrypted before being transmitted, the information remains protected while traveling between systems. Even if traffic were intercepted during transmission, the attacker would only see unreadable ciphertext instead of the original plaintext data. Without the correct decryption credentials, the encrypted information cannot be restored or understood. This is one of the core concepts behind secure communication technologies used every day in cybersecurity, including VPNs, HTTPS websites, secure messaging platforms, and encrypted file transfers. Now that we've covered the core concepts, let's review the objectives for the live demonstration. For this live demonstration, I'll walk through the complete encryption and secure transmission process from start to finish. First, I'll create a file containing sensitive plaintext data. Next, I'll use GPG symmetric encryption to protect the file with a secure passphrase. After the file is encrypted, I'll transfer the encrypted data across the network between virtual machines using a lightweight Python web server. Once transferred, we will validate the ciphertext remains unreadable without the correct decryption credentials. And finally, I'll decrypt the file and restore the original plaintext to demonstrate how authorized users can securely recover protected information. Now let's move into the live demonstration and walk through the encryption and secure transmission process step by step. In this demo, I'll be using an isolated virtual lab environment built inside Oracle VM VirtualBox. The demonstration includes a Kali Linux virtual machine, a Windows virtual machine, GPG encryption, and a lightweight Python HTTP server for secure file transmission and testing. I chose to use GPG because it's a widely used encryption tool that provides strong cryptographic protection for files and secure communication. I'm also using Python built-in HTTP server because it provides a simple and lightweight way to transfer files between systems inside the lab environment without requiring additional software or infrastructure. The goal of this demonstration is to show how sensitive data can be encrypted before transmission, remain protected while traveling across the network, and then securely decrypted only by authorized users with the correct credentials. Let's begin with navigation into the Windows directory and reviewing the plaintext file before encryption is applied. I already created a working directory called E2E demo for this project, so I'm starting by navigating to that directory. Inside the directory is a file containing sensitive plaintext data. Right now, the information is fully readable because the encryption has not yet been applied. I'll configure the encryption settings, create a strong passphrase, and associate the key with a user identity. The secure passphrase helps protect encrypted data from unauthorized access. Now that the encryption key has been created, I can use it to secure sensitive files. This command encrypts the plaintext using GPG symmetric encryption. After entering the secure passphrase, the readable plaintext will be converted into unreadable ciphertext. The file contents are now unreadable ciphertext. This demonstrates how encryption protects confidentiality by preventing unauthorized users from understanding the data. Next, I will securely transfer the encrypted files across the network between virtual machines. I will now use Python's built-in HTTP server to host the encrypted files across the network. This creates a lightweight local web server that allows another system in the lab environment to access the encrypted files. The Windows virtual machine, I'll connect to the Kali Linux system using an internal lab IP address. First, let's look at the unencrypted file. As you can see, message is in plain text. I will now download the encrypted file from the Kali Linux web server. Even after being transferred across the network, the data remains encrypted and unreadable without proper decryption credentials. This demonstrates secure transmission and confidentiality protection. I'll now return to Kali Linux and decrypt the file using the correct passphrase. This command decrypts the ciphertext and restores original plaintext data using the correct passphrase. The original plaintext data has now been successfully restored. This confirms that the encryption and decryption process worked correctly while keeping the data protected during transmission. That completes the live demonstration. Let's finish with a few key takeaways from this exercise. To wrap everything up, this demonstration shows how cryptography helps protect sensitive information through encryption and secure communication. We saw how readable plaintext data can be converted into unreadable ciphertext to support confidentiality and prevent unauthorized access. We also demonstrated how encrypted data remains protected while being transmitted across the network between systems. And finally, we used the correct decryption credentials to restore the encrypted file back to readable plaintext. These same concepts are widely used throughout cybersecurity today in technologies like VPNs, HTTPS websites, encrypted messaging platforms, secure file transfer, and enterprise data protection systems.
Thank you for watching Cyber in Practice. If you enjoyed this demonstration, stay tuned for future Cyber in Practice episodes.